Hello everyone, this is Guru Prasan K from 3D Fully Design. Here I would like to explore a flanged coupling and its design in 3D by using SolidWorks.
What is coupling? A coupling is a mechanical device used to couple two shafts for transmission of power. Flanged coupling consists of two flanges, one on each shaft, fixed with the help of keys, and two flanges connected together with the help of bolts. Some of its key applications: pipe connection and alignment, mechanical power transmission, pump and motor connections, pressurized piping systems, industrial machinery. Some references: these are the old electric railway flanged couplings of the year 1906. You could see its details. Old flanged coupling drawings from the year 1914. Here I will explore two types of flanged coupling: unprotected type and protected type. I begin with unprotected type. These are the inputs I would use to design this in SolidWorks. Shaft dia 40 mm, and you could see the item list with 7 items with alphabetical dimension parameters and item balloons. These are the approx proportionate equations, all based out of shaft dia 40 mm. These are the defined variables in SolidWorks for 3D design. Defined variables with their final equated values and their descriptive names. The final 3D design of protected and unprotected type flanged coupling. We do 2D and 3D trainings for students. First and foremost, I would begin with item 3, which is flange mail made out of cast iron. All dimensions are in mm. The very first sketch, rectangle of OD 160 and width 64 for full stock size. Solidifying with revolution to make full stock size of flange mail, which is of cast iron. Sketched for ID cut of dia 40. By using cut revolve, making ID cut of dia 40 on the flange mail. Sketched for two OD cuts of hub dia 80 and spigot dia 60, which will result in a flange thickness of 20 mm. By using cut revolve, making two OD cuts for hub and spigot with a flange thickness of 20 mm. Drilled 4 through holes of dia 10 equally on a PCD of 120 on the flange for bolting. Sketched for the keyway of 70 length and 8 height with 1:100 taper ratio. By using symmetric cut extrude, making keyway on the flange mail for a depth of 12 mm. Lastly, did rounding and beveling to get rid of sharp edges. Next, I would begin with item number 2, key long, which is of mild steel. Sketched for key long of 70 length with 1:100 taper ratio. With symmetric extrude, made key long for a depth of 12 mm. Next, I would begin with item number 4, flange female, which is of cast iron. Flange female is identical in sizes to flange male except socket cut and keyway position. Same as flange male, full stock size of dia 160 by 60 wide. Same as flange male, ID cut of dia 40. Sketched and by using cut revolve, made OD cut of dia 80 for the hub and for a flange thickness of 20 mm. Sketch for socket cut of dia 60 and 6 depth. By using cut revolve, making socket cut of 60 dia and 6 depth and cross-sectioning it. Same as flange male, drilled 4 holes of dia 10 equally on a PCD of 120. Sketched for the keyway of length 63 and with 1:100 taper ratio. By using symmetric cut extrude, making keyway of 12 width which is placed perpendicular to flange male keyway. Finally added rounds and bevels to get rid of sharp edges. Next I would proceed with item number 5, key short, which is of mild steel. By using same sketch of keyway, made key of width 12 mm with symmetric extrude. Next I would do item number 1, shaft end, which is of steel. Sketched for the shaft end of OD 40 and arbitrary length. Using revolve, created the shaft end of OD 40 mm and arbitrary length. Sketched a slot for keyway on the shaft of width 12. Making keyway of depth 4 mm on the shaft end. And beveled to get rid of sharp edges. Let's begin the assembly operation. Inserted and placed the first component, flange male, in an assembly environment. Inserting and fitting the shaft to flange male properly with concentric and coincident mates. Inserting and fitting the key long into shaft and flange male through coincident mates. Inserted and placed the flange female. Same as before, inserted and fitted the shaft into flange female through proper mates. Fitting the key short into shaft and flange female through proper mates. Fitted flange female to flange male with coincident and aligned through concentric mates. M10 by 52 bolt and M10 nut pulled and inserted from the toolbox. Finally, flanges bolted together with M10 bolt and nut and duplicated it to 4 numbers equally. Internal view with half cross sections of the flanges. You could visualize shafts and keys are positioned 90 degrees apart. Assembly animation of unprotected type flanged coupling. Let's begin with protected type. Protected type will have shroud on the flanges for protection. Let's build the shroud for flange male. Sketched 2 offset circles with 4 mm thick on the edge. Created the shroud on flange male of depth 12 mm and cross-sectioning it. Exactly same as flange male, created shroud on flange female. Final assembly of protected type flanged coupling along with half cross sections of flanges. Protected type assembly animation. Unprotected type cross section view with bomb and balloons. protected type cross-section view with bomb and balloons. This is about my certifications. Please subscribe 3D Fully Design.